Hmm. So, Hi everyone. Thank you for joining this conference. My name is Kani Yuan, and the topic of my presentation is My River. It is a microplastic filtration device designed to employ in the freshwater ecosystem. So, my research paper is titled An Internet of Things: Sustainable Water Filtering and Monitoring System Using Big Data Analysis and Clean Energy. So, first of all, what are microplastics? They're known as MP, and they are plastic particles less than 5 millimeters, and they're extremely pervasive. And did you know that our oceans harbor an estimated 5.25 trillion plastic particles, and they weigh nearly 270,000 tons? So MPs are everywhere. They can be found in the water you're drinking, in the air that you breathe, even the fish that humans consume. So microplastics, they're extremely widespread. So what are the problems of microplastics? So they can carry various toxins such as heavy metals, and they release toxic substances into the soil and water. And it is impossible to prevent from ingesting these plastic particles. And once they're ingested into the body, it is really difficult to digest. And humans consume about 5 grams of microplastics every week. That's similar to eating a credit card every week. And the graph on the bottom right shows the number of MPs per cubic meter starting from 2008. It emphasizes that MPs are the concern because they're growing exponentially every year. So when digested, MPs can cause various diseases, including cancer and many more. They can also cause big issues for aquatic life. This is a global environmental issue that is often neglected by people. So everyone must take action, and this is our goal, to not only physically remove MPs, but also spread awareness of the issues associated with these small plastic particles. So most importantly, there are limited solutions to this problem, and most people don't realize the existence of MPs and their associated danger. A significant portion of microplastics originated from rivers and lakes due to the pollution from factories in urban areas. So our approach can therefore be to design an microplastic removal device to deploy in the freshwater ecosystem, and this will solve the problem. So introducing our methodology is called MyRiver. So it has a hardware and a software. It is cost-effective, high-tech, automated, meaning low maintenance, and uses sustainable energy. And most importantly, it is eco-friendly. So here are the parts. We have, since MyRiver uses sustainable energy, we incorporated 2 solar panels for powering the electronics. And to remove the microplastics in the river, we have an MP filter to filter out the um, water and trap the microplastics. This MP filter container is made using a clay pot. Due to the porosity nature of clay, it can leak water, which will speed up the process of filtering. It can also purify water. And MyRiver also includes a microcontroller that serves as the brain of the whole system. Uh, it is responsible for interpret inter it, it is responsible for interpreting the data from the sensors and sending it to our database. The sensor we use here is a TDS sensor. TDS stands for total dissolved solids, meaning it measures the total dissolved solids in the water. And this sensor is extremely useful in this scenario because it not only provides a general view of the water quality, but can also detect the early stage of algae bloom. So the working process of MyRiver involves the 12-volt solar panel powering the pump to supply water into the MP filter, in which clean water will flow back to the river and microplastics are retained. They're like stuck in the filter. And the smaller solar panel charges the 400 milliamp per hour battery inside the waterproof electronics box. This battery will also give power to the microcontroller to receive data from the two sensors, which are TDS sensor and temperature sensor, and it will send that data to our database. Since my river relies on solar power, when there is no or weak sunlight, the water pump will stop working and the filtration process will be paused. So this MP filter consists of 4 layers. It has river rocks, coarse sand, fine sand, and cloth. As you go down to each layer, the porosity distribution decreases, meaning the layer is more refined. And this filter can successfully tackle every possible size of microplastic because the porosity distribution for cloth is 0.05 microns, but the small size of microplastics is only 1.6 microns. Meaning all the microplastics will get trapped. And fast fashion industries created a lot of textile waste. And since the goal is to make this product as eco-friendly as possible, it is reasonable to reuse the waste as the cloth layer. So, and we also have a software, and it is developed using Flutter. It is extremely eco-friendly to give customer a good experience to check real-time data, and it is available to both platform users. The database is built using Firebase. So to navigate the app, you can first log in or sign up. Then if you purchase a device, you can register it using the unique ID that every device has. From there, you can press refresh button to see the real-time data. And the real-time data updates every 5 seconds for accuracy. Here's the device registration page where you can add more devices. Here's the account page if you want to log out or delete the account. And then FAQ page to answer any questions that you might have. So here is the video demo. Let me play it. So we can see that the water is being pumped into the filter, and the clean water will flow back to the river. Okay, so next. So this is an alternative solution analysis. So as we can see, these companies have these companies offer wastewater treatment plants, but they are not cost effective, and each plant requires from $500,000 to $1.5 million, and they require more maintenance afterwards. They are not eco-friendly because they are a source of nitrogen and phosphorus pollution. They're not innovative because every wastewater treatment plant is somehow similar to one another, and they're not portable because they have a huge size. Modern wastewater treatment plants are indeed mostly automated and they're scalable, but does not mean that these advantages can overcome their mass weaknesses. For example, underdeveloped places may not have the funds to buy wastewater treatment plants. On the other hand, my river features all of these imperative qualities and is a more affordable solution. So here's our experiment data. So when my river runs for an hour, it can remove about 5% of microplastics. And we created a prediction curve to simulate the removal percentage. And indeed, my river does need some upgrades, but the prototype does offer some promising results. And we could partner up with NGOs, government organizations, and environmental agencies to deploy my rivers and help remove microplastics from the freshwater ecosystem. For future development, we will add more sensors for better accuracy and transform my river into a buoyant system to make it floatable. So it has no restrictions on where to deploy. And we can incorporate machine learning and AI to make further predictions. And we can upgrade the microplastic filter for effectiveness and many more. So in summary, my river is eco-friendly, high-tech, automated, affordable, cost-effective, uses sustainable energy, and it takes a novel approach to solve microplastic pollution. And together we can build a better future by protecting our environment. So thank you for listening to this presentation. Any questions or comments?